Welcome to the Learning Lab. Today what we're going to show you is we're going to show you our product line consisting of lasers and red light therapies. So I'm going to show you the three products that we have available for medical centers and for individuals who want to purchase our products. But what I want to do first is I want to give you a little bit of an education on how it is that red light therapy helps individuals stay healthier. Now, the explanation is really based on physics and the conservation of energy and the ability to introduce energy into a human bodies through frequencies that we call light, what we see as light. Light comes in many different colors. The red light, the one that's emanating at a particular frequency, which our eyes interpret as the color red, is the one that's most easily absorbed by our cells, which our cells use in order to establish or to create a different type of energy domain in them. But so the idea behind red light therapy really is something as simple as just introducing an energy in the form of light that the cells are able to absorb. And the reason that they're able to absorb it is because the light energy is being transmitted, the red light energy, light, is being transmitted at a particular frequency that's just the right size that interacts with the cell bodies. And that's, in essence, that's one of the reasons why cells and the human body respond so favorably to red light therapy. Now, the whole idea behind this ability by cells, this ability of cells to absorb the energy, and then what happens after, it has to do with the conservation of energy. Now, there are many formulas depending on the physical domain that you're applying the conservation of energy definition to. The whole idea is the same whether you're talking about a chemical reaction, a reaction of mechanical origin, or whatever it may be. It's you always, no matter in every single system, and every single closed system, an open system that interacts with the environment, energy, as we all know, cannot be destroyed. Energy always stays constant. So when a healthy cell is at its healthy state, it is operating at a particular energy state. A cell that is not normal and is degenerating or it's coming undone is operating at a much lower energy state. So in essence, this is kind of how red light helps. So this is a formula. You have KE stands for kinetic energy, PE equals to potential energy, equals to KE plus PE. This is nothing more than just a simplified form of a conservation of energy formula having to do with a mechanical movement or mechanical load. These two energy states right here will always be the same. What changes is these variables right here relative to the other side of the equation. Now, in a chemical domain, the conservation of energy still stays the same. One way that you can explain it or formalize this is very simple. When a cell is in a degenerative state, it's operating at a very low energy state. When it's operating in a normal state, a healthy state, it's operating at a higher energy potential. The lower degenerating cell is operating in a very limited potential state. It doesn't have as many options, as many realities to assume because it's degenerating and coming undone. So when you introduce a red light therapy or a frequency in a particular wavelength to a cell that is in either of these states, let's say this is the waveform right here, and the perfect waveform for the human body is at that 660 to 680 nanometer, which our eyes interpret as the color red. What's happening is when you introduce your body to this red light or a very focused beam in a particular frequency, these cells that are operating in one of two states, either healthy or in a degenerative condition, these cells are operating in a particular energy state. When you introduce the light, you create something that we call in the red light industry as optical molasses. Optical molasses, that's what it's called. This is a physical term, but it has biological application. When you introduce this red light or a very focused beam to the human body or an area of the body that's in a degenerative state, you're creating this optical molasses condition, which in essence all it is that when the cell interacts with the light, it captures the cell. It captures it. It's kind of like a magnet. It captures the cell, and when it captures the cell interacts with this light, and it changes the energy state. The cell, what it does is, it's moving. It has momentum. It exchanges its momentum to a higher energy state. It's moving around very randomly. It has momentum. Especially a cell that's in a degenerative state, it's moving around a lot. It has no stability. So when it interacts with this red frequency, it exchanges this movement to a higher energy state. It decreases momentum and it increases the potential of a different energy state, conserving the energy, abiding by the conservation of energy. You're introducing energy into the cell. The cell is converting one of its physical properties to maintain the conservation of energy within its state. So it removes one of the physical properties that's degenerative in nature. That's kind of like a simplified version of what's happening, but in essence, that's what's happening when you're introducing a red light therapy or red light energy onto the human body. Now, if any of you have seen our devices here, we'll just show it to you real quickly. We've got this one right here, which we introduced it the other day. This is our body red spectrum system, and then we have this smaller version, which is our joint version. Again, they're all emanating at that 680 nanometer range. It's very specific. This is our joint version, and the other one is our body. It's a whole body version. What I'm going to introduce to you today, which is the basis of our video, is I'm going to introduce you to the class 4 laser. And we're going to use my assistant, Anna, here in helping us show you how the system works. This is a very focused, high energy photon beam. It's a class 4 laser, and for the first time I'm going to show it to the public so you can appreciate how it is. This is one of those systems that we use when we introduce a biological treatment, because we want to capture those young cells into the joint itself and draw it into the damaged joint. So Ana, what you're going to do, you're going to te vas a acostar boca arriba. No boca arriba. Now, for this procedure, you definitely have to protect the eyes. You protect the eyes. So we're going to protect the eyes of my colleague over here, Carlos, who's running the camera, and I'm going to show you the system itself. This is it right here. This is it right here. This is a class 4 laser. These things usually run in the tens of thousands of dollars. But we manufacture ours in a special OEM that we've been working with for a while. It's a high-tech OEM, so we get prices that are far below anybody else's in the market. So we're able to pass on that savings to medical centers, etc. We don't sell these units to everyone. We sell them only to medical centers who are involved in treatments of biologics. But we do use them for class 4 or grade 4 types of degenerative conditions of the joint, because again, it's a very tight focused beam, and you're introducing a very high dense photonic energy stimulation into the joint. So we're able to capture and change the energy states of these cells that are in a degenerative condition. And in essence, that's what we want to do. We want to raise the energy level of a cell that's in a very low entropic limited energy state. And that's what this does. That's what red light therapy, in essence, that's what it does. It creates this optical molasses. So I'm going to show you now so you can appreciate it. Okay, now you're seeing here the beam. You can see the beam right here. I'm shining it here on the board, on the whiteboard here. You see how it scatters. It's a very dense beam. Now this is very little wattage. This does not generate any heat, because the energy that we want is not in the form of thermal. Thermal is an energy, but it's not a very efficient energy. It's very superficial. So we don't want thermal energy. If you want thermal energy, you get yourself a hot pack, and that's all you need. So this beam is very safe. It's 700. It's in the micro wattage. It's only micro wattage. It's very low wattage because we don't want heat. What we want is just the photons emanating at a 680 nanometer range, which is basically what this is, but it's a very tight beam. I don't know if the camera can appreciate it, but you can appreciate it with the eyes. You can actually see the beam. It's very safe to use on joints. There is no safety concerns here. Okay, so now let's say that Anna had a knee issue. The treatment is 5 minutes. The treatment is 5 minutes. You concentrate it on the area where all the degeneration is. If, let's say it's on the medial side, that's where I would focus my beam on. It's only a 5-minute treatment. That's all it is. It's just a 5-minute treatment. So we just move. It's timed. Everybody's wearing glasses in the room, excluding the patients. Everybody that's in the room is always wearing safety goggles because there is a lot of scattering here. The scattering is part of what creates this optical molasses. So if you time it 5 minutes, the 5 minutes is up, you turn it off. It's as simple as that. You turn it off. It's off. Everybody can take the glasses off, and it's done. And that's in essence how this works. That's how this works. This is a class 4 laser, extremely relatively priced fairly. There's no price gouging here. We only sell it to biologics medical center, but we do use it in our centers, obviously, because again, with these grade 4 severely involved knee joints, we want to focus in the beam so we can create this optical molasses at the joints and change that energy state of the cells that are in a degenerative condition. So again, these other 2 units that I showed you earlier, they're in essence these are not lasers. This is red light. This is a very diluted beam. But again, it's used in a very different format, and it has different applications. These are units that can be used at home with extreme safety. So these other units that I showed you, these are red light therapy. These are not lasers. The one that I showed you a little while ago, that's laser. But these home units can be used safely at home, and they more or less accomplish the same thing. And they're relative. They can be used every single day. But irrespective of whether it's a tight beam or a diluted beam, the principles are always the same. You're trying to change the energy state of the cells themselves from a very low potential, having very limited flexibility, to one whose entropic profile is much more expanded. So they can have different possibilities. The optimal possibilities that we want always, obviously, is a cell that's functionally in a symbiotic relationship with its other cells around the area that's involved. And in essence, this is our product line right here. We're always expanding, always evolving, always making the product better, and always looking to provide the best possible system for people to own and medical centers to use. Okay, anybody watching this video, thank you very much. Until next time.